Have you ever heard about someone who believed in the prophecy that said he would die 3 days before his 75th birthday? For fear that his prediction would not work, he went on hunger strike to die on the correct day of the prophecy. Sounds quite insane, but he was actually one of the greatest mathematicians of the 16th century, Gerolamo Cardano. Gerolamo Cardano was an Italian mathematician who was born in 1501 and passed away in 1576. Mathematics to medicine, biology, physics, chemistry, astronomy, philosophy, and Renaissance linguistics. Cardano grew up in an unhappy family and lived under depression, frequent illnesses, and even impotence. However, when he went to university, he chose to pursue his passion for medicine and successfully demonstrated his genius. Cardano was consulted by many members of the College of Physicians for his undeniable intelligence. 1484, the Italian Luca Pacioli produced his volume titled Summa de Arithmetic, which laid out a challenge to the Italian mathematical community. Later, Del Ferro discovered a formula that solved the so-called depressed qubit of the form ax cubed plus cx plus d equals 0. Instead of publishing his solution, Del Ferro kept it a secret until his death, telling his student Antonio Fiore. Tartaglia then claimed to know the solution to the cubics of the form ax cubed plus bx squared plus d equals 0. Tartaglia sent Fiore a list of 30 various mathematical problems, and Fiore in turn sent Tartaglia a list of 30 depressed cubics, placing Tartaglia in the bind. He worked furiously trying to find a solution to the depressed cubics, and on the night of February the 13th, 1535, he discovered the solution. Tartaglia prevailed in the challenge. His victory made him something of a celebrity. Mathematicians were desperate to learn how he solved the cubic, especially Gerolamo Cardano. He refused to reveal. He wrote a series of letters that alternate between flattery and aggressive attacks. Eventually, with the promise of an introduction to his wealthy benefactor, Cardano managed to lure Tartaglia to Milan, and there on March the 25th of 1539, Tartaglia revealed his method, but only after forcing Cardano to swear on a solemn oath not to tell anyone the method. Cardano was delighted and immediately started playing around with Tartaglia's algorithm. But he had a loftier goal in mind, a solution to the full cubic equation, including the x-squared term, and amazingly he discovered it. If you substitute for x minus b over 3a, then only x-squared terms cancel out. This is the way to turn any general cubic equation into a depressed qubit, which can then be solved by Tartaglia's formula. Cardano was so excited to have solved the problem that stumped the best mathematicians for thousands of years. He wanted to publish it. The only problem was the oath he swore to Tartaglia, who wouldn't let him break it. But in 1542, Cardano met a mathematician who just happened to be the son-in-law of Scipione de Ferro. Cardano found the solution in de Ferro's old notebook. This solution had predated Tartaglia's by decades, so now, as Cardano saw it, he could publish the full solution to the qubit without violating his oath to Tartaglia. 3 years later, Cardano published Ars Magna, the Great Art, an updated compendium of mathematics. Cardano wrote a chapter with a unique geometric proof for each of the 13 arrangements of the cubic equation. Cardano was writing Ars Magna, he came across some cubic equations that couldn't be easily solved in the usual way, like x cubed equals 15x plus 4. Plugging this into the algorithm yielded a solution that contained the square roots of negative numbers. Cardano worked back through the geometric derivation of a similar problem to see exactly what went wrong. While the 3D cube slicing and rearrangement worked just fine, the final quadratic completing the square step led to a geometric paradox. Cardano found part of the square that must have an area of 30, but also sides of length 5. Since the full square had an area of 75 to complete the square, Cardano had to somehow add a negative area. That was where the square roots of negatives come from. the idea of negative area. Now, this isn't the first time square roots of negatives show up in mathematics. In fact, earlier in Ars Magna is this problem. Find two numbers that add to 10 and multiply into 40. You can combine these equations into the quadratic x squared plus 40 equals 10x. But if you plug this into the quadratic formula, the solution contains the square roots of negatives. The obvious conclusion is that a solution does not exist, which you can verify by looking at the original problem. There are no two real numbers which add to 10 and multiply to 40. Having more than 200 works across multiple fields ranging from mathematics, medicine and physics to philosophy, religion and even music. Up until now, Gerolamo Cardano is still considered one of the greatest mathematicians because of his contributions in the field of algebra.